Hello guys, hello everybody, welcome back again. We just finished our video on the sending hardware information or sensor information from our hardware to the web server using the asynchronous web server with ESP32. So today we'll continue with the other direction, which is still unidirectional, but sending information from our web server to our hardware, okay, which is the ESP32. And for this simple task, I'll use a 4-digit LED display and an RGB LED, which stands for red, green, and blue. So this is our display, and we'll be using it for timing. And this is our RGB LED. And for this LED, I'm using a common cathode. Common cathode just means that the common pin is connected to ground, because cathode means negative, okay? You can set it as a common anode. Then in that case, you have to connect this common to VCC, okay? So cool. And let me just show you a little bit of what we'll be learning into this one. So let me get into our main and then F1 and then start simulation. So if everything is cool, our simulator will get started. It will connect to the Wi-Fi, and after connection, if the connection is successful, it will notify the next task, which will be the server task, and then start displaying information. So you can see here, it says connecting to Wi-Fi, and then get connected. And we display the IP address of the Wi-Fi and also the local host, which is at port 8180. By clicking on this port, it will open a web browser that you can see here, and it says 7-segment display, and this is four digit, okay? I'm calling it 7-segment. So yeah, now what we are learning, as you can see here, there's no input. How can I do this? Let me do this, something like this. Okay, and then bring this one and then close the file and also reduce copilot. Okay, cool. I think this is enough. And bring this one here. One thing that we can see is that there's no input element on our diagram side. So normally, if you want, for example, this one to start counting, you need either a push button or a switch. You press the switch, then it starts counting. When you press the switch back, then stop. And then if you want to continue, you also press it. So we don't have any of that. So we are using the website as our UI or as our user interface, okay? This will be like our input side, and our hardware should receive the information from the website and then perform it on the hardware level. So let's say, for example, if you want our counter to start, we just click on this, and you can see that the counter will start counting. And if we want to stop, you click on stop, and you will see that the counter will stop. And if you want to continue, just click on it, and you see here it said stopped. And if you want to run, you click on it and it start running. When you start running, you can see that it will also start counting on this side. That is cool, right? Same thing for our LED. So I'll stop it. Let's say, for example, I want this LED to be red, so I'll just switch this one up. And you will also see on the serial monitor that we display the level, okay, of brightness of our LED. Right now it's at 244, which is the maximum is 255 that we can set to. So red is right now at 255, and you can see everything is red. So let's say, for example, I add a little bit of green to it. So what will happen? I bring green to 80. It becomes almost yellow, and you can see here green is 80. So let me remove the entire red. So we should have a little bit of green in over there, and you can see red 0, blue 0, but uh, green 80. If I bring it to the maximum, the LED becomes completely red. And as we are doing that, this can also be counting at the same time. Don't you think that that is awesome? So let's go into the code and see how the codes perform. So we get entire green, and then let me stop the counter so you can see. I'll add a little bit of green to it, and you can see the color. I don't know which color is that, and I can add much more red. Ooh, it becomes almost white. So let me bring it back. Okay, which color is that? I don't know. So let me bring this one higher. I don't know which color is that. So let me bring this one back. So we get to, ooh, this color is nice. So guys, welcome back, and let's continue with our simulation of ESP32 in Wokwi. So cool. Sorry guys, I forgot to bring back to our thing. So yeah, we were simulating this, and I'll close this, then we go to the code for us to explain. I'll also bring this one down because not that much needed. So good. So far, so good. So as we are with the web server, we are today working on how to send information from our web page to our hardware using Wokwi ESP32. So very simple here. First, this is our HTML file. As you can see, it has a body, it has a styling part using CSS, and it has a JavaScript part that will get element ID and then display each of them. For example, the slider and the button that we have, or the switch that we have. And all of this is being converted into one variable that is called main page. And this main page should be passed by a certain function that we will get, and that function uh, isn't called here, but anyway, yeah, it's called here. It's called the uh, handle RGBT. But anyway, so I'll explain each of these functions into our main. So the very first one is our web page. If we want to know how the web page looks like, you just have to copy the HTML section of the code and then create an HTML file here. I'll call it test.html, and we can get into this and see how it looks like by running it onto a live server. And I think it will give us the board on which is running, but you can see how it looks like. Nice, right? So this is how our web page will be looking like. Okay, this is the HTML file that we've developed. If you think that this is okay, if you don't want to change the color, if you don't want to change anything, yeah, it's up to you. You can still change into the HTML file here. And as you can see, the HTML file has three different parts. It has the HTML file itself, it has the styling part, which is this one, and finally it has a script section, which is this. So this is the HTML itself, this div part where we have all the span and everything on the body side, and this is the styling of our HTML using CSS code. And finally, for smartness and interactivity or responsiveness of our website, we are using the script function, which is the script section, which is using some functions of JavaScript, because this get element by ID, get element by ID, all this shit are from JavaScript. Really, I don't like that much, but yeah, anyway, we good with this. I'll close this. It's not needed. I'll even delete it. So we now take all of this, we convert it as one single variable that we'll call it main page. Good. It's a char or a character. Then let's get back to our main.h. So this header file is the header file of our main.cpp. When we start our main.cpp, we need to call this header file because it has some macros that have been defined here. And I hope you already know how header files are being defined. So here is a directive, a macro that tells our compiler to use the variables or to use these files only once. Okay, so it will go through. If there's any file called main.h or main.h, call it only once. It's called a once. Yeah, anyway, it's a macro that just tell the compiler to only use this files once. And in here we have our other header files that are needed. So for this whole project to work, you need this header files from the timer 1637. You need the Wi-Fi library, you need the asynchronous TCP protocol header files, and you also need the asynchronous ESP32 web server header file. And this, it's me who develop it by myself, so that's why you can see it's into double quotation. So this header file is directly here. So if you click on this, it will open this header file that we just talked about. And this is our web server or our HTML file. We good up to here. Now here we define some hardware configuration pin layout. First, the clock. So the TM or the timer has a clock pin. It has a data out pin, and this is not needed. I will remove it. So it is a stop GPIO if you want to connect to it. And then we get also our other component or element, which is our RGB LED. So our RGB LED has 4 pins. One is the red pin, the other one is the green pin, the other one is the blue pin, and the final one is the common pin. Each of these are, for example, the positive side. Now they need their negative side, which is the common, okay? And that common, in my case, I'm making it as a common negative grounded, which means a common cathode LED. So you can see it here. Let me launch this schema, the diagram, so that we can see. So this is the red, this is the green, and this is the blue, and this is the common to all of these three. And this common, I'm making it as a common negative, or it's called a common cathode LED. So that is directly connected to our ground here. We were here. We finished with our pin layout or the diagram, how elements are connected to our microcontroller. Then I create a struct here which will hold the value of the red, the green, and the blue from our website. So when we launch the website, we need those values, the red, the green, and the blue. They will be integers. We need a struct to hold those values and then write them to the corresponding GPIOs. So that's why I'm creating this struct here to hold first those values from the website and then write it to different GPIOs depending on their colors. And these are some external queue handling for FreeRTOS. And this is for our timer. Okay, we instantiate an element of this class. So this is the class, which is called the TM1637, which is a timer. And this is an instance of this class that we are getting from this. And this external just means that this is not directly called into this function. It's an external. It's from the library, from you can see here, okay? Groove something something. So this library, you can get it on GitHub, you can get it anywhere else. It's just for a timer, 4-digit display LEDs. Okay, so all of these word external just means they are not directly into our header file that we are defining here. Okay, they are from external, they are from these libraries. Okay, good. So then we also, from the API of FreeRTOS, we get a small file that will handle tasks and sync them, and we call it a mutex, okay, a counter. Then from our web server or the asynchronous web server library, which is from this, we instantiate an object from the asynchronous web server class, and we call that object server or that instance server, and we'll call it into our main.cpp. Same thing for these ones. Now these are function declarations. They are not a must, but it is important. Okay, they are also called function prototypes or function declarations. So we have the display task function, we have the counter task function. So this display task function will be displaying the value to our LED or our 4-digit display LED. And this counter, it's the task that controls the stop and continue uh, state of our LED of this task. Okay, and this function will be handling our RGB LEDs from the web server side. For example, how to pass all of the value from the web server and then save them into this struct. So this function will be in charge of that. And finally, we have a task. This task, which is the RGB task, will be writing these values to our LED. So let's first start with the task display, which is a very simple one. So as you can see here, this task here, task display. So the objects that were initialized into the main.cpp main.h, they are now called here. For example, we create this instance. Okay, the TM that was called over there on the timer, we set its clock and its data as this. Okay, we also create an integer, which is a counter integer, and then from the API of FreeRTOS, the semaphore that we defined here, we can call it here as a counter max, which will help us also with syncing all of our tasks. They are used for notification and they are used also for syncing tasks based on timing, okay, or counting. And then we create a port, a server port, which is port 80. And yep, the queue, and this is also from FreeRTOS. So the first task, which is a task display, it doesn't have any set of functions, so you can see there's nothing being done before. It's only in the while loop here, and it's a very, very simple one. So we first start with the semaphore, and this is a tick. So that means there's a give somewhere, okay? So, and this is what we initialize as our semaphore for task handling. Okay, so all of this is used for syncing tasks. Okay, for FreeRTOS API, you can copy this and then go onto FreeRTOS or whatever Google paste, and then you see each of them. What are their parameters and their delay task for each port? Okay, and this display just means on the 0 and on the 1 and on the 2 and the 3 what to display. Okay, let me just show you what I'm talking about. I don't know if you can see, if it is not on here. So here, this, and this. We have 4 digits here. So those 4 digits, what to display on each of them. Okay. So this is what we've, so for example, on 0, you will display this remaining counter divided by 1000. The remaining value of that, that's what we'll be displaying. Okay. On counter number 4, no, or LED or digit number 4, you get the counter, okay, divided by 10 and then write the remaining of that out there. So that means counter number 4 here will get bigger values, and counter number 0 will get, okay, smaller values, or reverse. So if you have for example 0 and then 1 and then 2 and then 3, so this will be like it will start counting from here. 0, 1, 2, 3, 4, 5, 6. If this is full, the division of 10 of this counter divided by 10 will be displayed here. And if it's 100, the division of 100 divided by the division of this counter value divided by 100 will be displayed onto these 2 digits. Same thing when it's 1000. Okay, so exactly that is being done here into this display. Very simple task. So if you want to display, for example, 9, you know that 9 divided by 10, the remaining will be displayed on this digit number 4. Same thing, if you're at 100, so that will also be here. And if you are at 1000, that will be somewhere there. So that is this first task. The second task is the counter task. And this task is just here to stop and continue from where we left. Okay, very simple. So if the counter is 1000, then you set the counter to 0. Okay, if it is not, you keep on counting. Because if we reach, for example, 1000 from here, so let me just show you what this task does, okay, before we move on. So press F1 and then start simulation. That will take time, but I'm sorry for that, because as beginners, we need to test things and then see if they are true, what we are doing. So that task will only help us this task will only help us know if our LED gets, if our display get restart. So it will count when it gets 1000, it should go to 0. That is what that task is doing. So let's start counting first. So it says it's running. So this is 9, 10. Then this will get to 100. This will get to 1000. And when it gets to this value, the biggest value, it should reset this whole thing to 0 and then restart. So that is what that task is doing. Okay. And if that is not the case, it should keep on continuing. And also, this stop and then continue button should also be synced, because you don't want when you stop, okay, and when you start going, it goes to 0. So when you say continue, it should continue from where it stops, okay, running. And we can also edit this to make it to go to 0 whenever we stop, okay. If there's a counter that we want, for example, you press the counter, you start counting to 30 seconds, and then when you stop, it goes back to 0. And then, for example, the other athlete, and then you press and then it goes up to, you try to see which, okay, athlete, or which function or which task takes too much time, so you can use that. We can also do that, instead of we just, where we stop, continue counting from there, we can reset at any time that we stop the clock. So what we want to test here is if this get to here, like 9999, what should happen? It should normally reset, instead of um, overflowing our whole bus or our whole LED, 4-digit LED display. So that's what we want to test, and this should happen at this task here. So you can see here, if counter is equals to 10,000, we set the counter to 0. If the counter is not that value, then keep on counting whenever we stop and resume. So this is for this task. Very simple. So these two tasks, they are very, very simple. Now this one is a little bit complicated, because it's everything from the web and being displayed. So what we are doing here is that we are first calling our struct, and that struct is defined in here, okay, that value. When we call that struct, these values are set to 0, 0, 0, and you can see here 0, 0, 0, 0, okay. You can define at start to be a certain value, okay. You can set this one to 10, this one to 20. So whenever you start, this will go to 10, this will 20, and so on and so forth. But we initialize them as 0, 0, 0, 0. Now, while our function is true, while this task is being performed, we need to get these values and then write them to these GPIOs. So this is the writing section where we write all of them. But if you are writing things, you first need to get them. For you to get them, you need to call the handle RGB function. And this function, what it's doing is routing first. It goes to has param function of the server, which is from the request. And if it has a parameter, it should write it. So the first thing is, if the red parameter has value, it should get those values. If the green slider has updated values from the has param function, it should also get it. And then when it gets them, we need to write these ones, right? Because that's where we are writing here, rgb.r. Now, if you want to write this function, you need to get it from here. So here's where we get into the request. We get that, and then we convert it into an integer. When we convert into an integer, we write it here. When you write it here, for sure, the color will get changed. Okay, so very simple. And then this is just for us to print it into a serial monitor, not important. And then we are requesting this every 200 milliseconds into the queue. I hope this is okay. If there's no update value, nothing get changed, then you just get into this missing page handler. Very simple, right? And these ones are not that really important. So it's starting the Wi-Fi, passing the credential of the Wi-Fi, and then see if it gets connected. If it gets connected, then print the credential of our Wi-Fi, which is its IP or the forwarded IP, which is our local host. And then we, with our asynchronous web server, we also need to route our web page. So this main page is our character, okay, or our string that is here. Okay, so we convert all of this HTML file into a variable that we are calling it main page, and then we route it into our HTML text template and then call it as main page, and we send it using the send parameter function of the server or the asynchronous web server for request. And after we sending it, then we need to populate also these other things. For example, what value is getting here. So for you to populate that, so then you need the second route, which is here, and also for the tagging. So if this one is running, it gets here blue and then it display running. So that it is done with this request that we are sending here. Okay, and then also the values, these values, when they get changed, we also need to update them here, for example, to 10 to 20 or some whatever. So that's what we're also doing into this tagular on server on. And yeah, now if you want also to limit the value of the RGBs, so you have to set up on this one and write them. Okay, the red to the red pin, green to the green pin, and yellow to the and blue to the blue pin. Okay, so this is the LEDC attached pin. Okay, so this is from free ESP32 Expressive, so it's just like PWM. Okay, so it just means LED control. Okay, the LEDC, so it's a function developed by Expressive to write you. It's just say PWM, so this PWM values that's being here, write it to these GPIOs. Simple as that. So that's what this one is doing here. And then we can also start our server on the HTTP GET. And when we get these ones, we write them directly to here. We get them here and then we write them here. So very simple. We are here, and the server begin. We know you need to begin the server. These tags I also explain all of them. For example, this is the tags function, this is the tags name, this is the tag size, this is the parameter, and this is the priority, and this is the handler if you are using task handler. Right now I'm not using any task handler because I'm using the sync, okay, from FreeRTOS, which is this. Okay, so it goes through each task. Oh, now we don't know if the thing was good or not. Yeah, for sure. It went to 0 because before we go, this was a bigger value. So when we are back and then it's a smaller value, so that means it reached 10,000 and then went back to 0. So guys, that is it for our first direction, where we are sending values from the web server to our hardware, which is our ESP32. And everything seems to be working perfectly as we expect. And you can see I'm also printing here the value of the RGB sliders. So that is it, guys. Thanks for watching this one, and then let's move on to something that I was just developing this afternoon. Because it's weekend, I also give these as a beginner stuff, only for beginners. Okay, there's software engineers, they already master these web server and web socket. So I'll first go with this asynchronous web server with Wokwi, and then we'll move on with web socket, which is much more better, sophisticated, and can be mapped to some other hosting on platform like cloud systems using maybe MQTT protocol. So guys, this is taking too much time. I cannot wait for it to go to that value, but stop and then resume. So if I say stop, you can say stop. And also you can see the local IP is being displayed here. So it just tells you, but this is useless because you cannot know it unless you have already opened it. So doesn't make that much sense, but at least it's important. So yeah guys, let's move on to something much more better, something a little bit advanced. So same thing, okay. Our last tutorial that was developed today that I will just show you guys is this. So also same thing. Right now what I'm doing is trying to combine two things, like sending to the web server and read it from the web server. This is not yet complete, but I will just show you as a demo, and you guys can also complete it, okay. I'll push all of this code to GitHub, and I'll share with you guys on YouTube the repository address and everything. It will be public. You guys can have access to it and you can modify. So what we are doing here is to read the values of the sensor, our DHT, and then display it onto our our LCD. And at the same time, we are now using WebSocket. Send these as a JSON file to the WebSocket, but also at the same time get it on the web server. So this first one is the web server using the HTTP, and then the second one here is the WebSocket server. So, but for this time, I'll just explain the HTTP section, which is the web server that we're using, the asynchronous web server. So the port is also 8180, and you can see here where I'm forwarding it. So I'm getting it from the local host, which is 8180, to our target port, which is 80, and that was also defined in here when we are initializing our object web server, which is here. Cool. So now let's first get to the HTTP web server. So I'll stop this one because we don't need it anymore. And yeah, that didn't work in the local host, but I think it's because the other port was already occupied. So what I will do is to stop our simulation and then restart it. If it doesn't work, just change the port, because the port was currently being used on this project here. All right, so let's wait. Yeah, we just restarted, and this microcontroller hasn't yet been online. So yep, it's now okay, and the Wi-Fi should get connected in a moment. Okay, if the Wi-Fi is connected, should start displaying our information, and I hope it's the same link. So let's click on it and then see if it will display that. And cool, we have it here. So what we are doing on this first one, these things are bad, but anyway, in this, I'll bring this one out here and then bring this one smaller. Nope, that is not what I want. I want this one to get smaller, and I want this one to get close, and that can allow me to bring this one out further. So you can see the temperature that is being displayed at 24. That's the same that we have here, and also the humidity level, which is 40%. So if we change this, for example, to a certain value like 55, you will see that the temperature, I got 55 here, I got 30 here. Okay, no, 54. The temperature got also updated here as 54, and the humidity didn't change. So if I update this one also to, let's say, 68.5, on the LCD side, it should get displayed here as 68.5, and same thing on our web server. So this is one direction. We sending from the hardware to our web server using asynchronous web server protocol. And let's say now that we want to send from the web server to our hardware, and you can see here that it's only when this change that will display the value of the position of our servo motor, and you can see that the servo motor is at 0. So if I change, for example, this one to 27 degree here, you'll see that our servo also moved to a certain degree, which is somewhere close, but this is not yet done. So you can see it goes back to 0 and not that much safe. So 110 and move way somewhere, it will go. Okay, yeah, this angle where it goes at the very first beginning was somewhere around 110, which is okay, and here 108. So this needs to be updated so that our code respond properly, and that will be the next topic of our work. So increase it, you will see also it will get increased to a certain level. All right, so guys, that is it. Let me bring it back to, let's say, 0, or and you will see in a moment it will go back to 0 degree, and our our servo motor will go down up to 0, and normally they should go back to 0. So that's what we need to work on right now with our AI model. But to make this video short enough for us, I won't be doing it with you guys. I'll just debug it in a moment and then display all of it. So right now he set 35 degree. So this will go back somewhere and then go closer to something around 35 degree and stays there. So the temperature, you can see I can change it to 19.5, and in a moment on the LCD side it should get updated to 19.5 degree, and also on the website side also should be the same thing. So guys, thanks so much for following this video with me. I'll update this one and then I'll start from it from our next video, where we'll now be doing the WebSocket, because right now I'm just showing you everything about the asynchronous web server. So but the most useful section of this is the web socket. So how can you, for example, send this information over WebSocket and then display it? So for example, this is the access point of my WebSocket, but also convert this as JSON files and send them to uh, a cloud system like Google Cloud, like Amazon Cloud, Alibaba Cloud, or Huawei Cloud, okay, using MQTT. And you can see that this value will be getting updated every second. The temperature should be sent. It said WebSocket sent temperature, WebSocket sent temperature and humidity. So, and you can use it, because most clouds use JSON files protocol. You can now display that one on your cloud system. So I'll just give you a blink of the code, how it looks like. So let me zoom this one out so you can see here. So this is the display. No, not this one, sorry. Not that one. Yeah, this. Not this. Sorry. Okay, yeah, this. So you can see here in our main, we have our DHT that is connected, we have our LCD that is connected, and we have our servo that is connected. So now these are what we are getting here. We have our display task, which is a very long task. We have our task WebSocket, which will handle everything related to the WebSocket, and then converting all of our stuff into JSON file and then sending it to the web server that we'll be using, or the cloud that we'll be using. And this is our WebSocket when it's on. And finally, we have our task sensor, and this task sensor work with our web server. Okay, the asynchronous web server, not the WebSocket. And yep, everything is pretty much as it is here. So as you can see here, when the server is on, we have a first section of our server, or our first route, which will be sending information using this Ajax. It's just JavaScript sheet, okay? And then we have a second one, which is also creating endpoints here. So we create endpoints to send values from the DHT to the web server, and we create another endpoint here for our server to receive information using this Ajax protocol from our web server or our web page to our servo motor. Okay, so it went through the request, check something called value, and that value is this param. So if this param has value, it get that value and convert it into an integer, and this is what we will write onto our server. Okay, our servo, sorry, onto our servo motor to move. So that's what will be getting updated, and based on that value, our servo can move to the specified degree. So I need to add all of the functionality of this function, and that will be the end of our very first section on this web server protocol, like sending, receiving. And then we will now continue with WebSocket, which is much more important. And after that, since this will also include MQTT and some other protocol for web storage, that will be a very good opportunity for us to also exercise most of our things. So the bidirectional one is not yet done, and that will be our last one. Although this one is sending, we also don't have any input from the hardware side. Like, we don't have any button that we are pressing and then getting the update of that on our web server. So that also can be added, where you get maybe an LED, maybe a relay, or maybe an LDR that you have here, and you move it and then you get the value. But also we have this one, which is an input, which is also important. So this, when I modify this, for example, to 53.5, I get a 50.5, and the same thing that I get also on the website here, 53.5. Okay, so there is it, guys. Thanks so much for watching this video with me, and let's take to the next one, where we'll do much more better and much more advanced things, but for beginners, as I'm saying, because I'm not a software engineer.